Hi guys, it's Miss Brown, and I want us to talk today about similar figures and proportionality. So in the previous video, I asked you guys to go ahead and start creating a notebook. These are notes, so these would be notes that I would like for you to place in your notebook. And the title of our paper is going to be Similar Figures and Proportionality. Okay, so first thing I want us to have is a definition of what similar figures are. So our definition is, oopsies. So our definition is figures that have the same shape but different sizes. And there are two characteristics that we really need to remember about similar figures. And the first characteristic is that corresponding angles are congruent. And just in case you don't know what corresponding means, let me go ahead and write that in. Corresponding means having the same position, okay? So angles that have the same position in two different figures. That's what corresponding means. And then some of you might not know what congruent means. You can think of the word congruent as just being equal. So when I'm telling you that corresponding angles are congruent, I'm telling you that angles that have the same position in similar shapes have equal measures. That's what I'm saying. Okay, so that's the first characteristic that we need to remember. The second characteristic that we need to remember is that corresponding sides are proportional. And the reason why we are talking about similar figures right now is because we have been studying proportionality and proportional relations for the month of September. So keep that in mind. Similar figures, figures that have the same shape, different size, corresponding angles are congruent, corresponding sides are proportional. So let's see what that looks like when we work with it in math. So I'm going to have a few examples. My first example tells us what to do if we are determining if figures are similar. Okay, so basically if we want to determine if figures are similar, the first thing we're going to do is write ratios. Remember, a ratio is just a fraction, okay? So we're going to write ratios for corresponding sides. And then the next thing we're going to do is we're going to check for the same unit rate. Okay, so let me show you what that looks like. So I'm going to draw 3 different triangles here, and we're going to try to identify if any of them are similar, and if so, which ones are similar. So here are my triangles. And this is triangle ABC. And we have side lengths of 3 and 4 right here. I'm going to put 5 there. And then here is my next triangle. And then I'm going to put side lengths of 9, 12, 15, and that's triangle DEF. And then my last triangle, I'm going to put side lengths of 5, 6.5, and 8. Okay, so if you look at my triangles, they all kind of look the same. So when we say similar, remember it has the same shape. You can't just look at it and say, oh, I think they have the same shape. You really have to do math to figure some things out. So the first thing I'm going to do is identify corresponding sides. And I'm going to use a highlighter to help me here. If you look at side AB, okay, that would correspond to the middle triangle, side DE. Remember, correspond means have the same position, which would correspond to the last triangle. And this is actually side XY. I have to go back and put my letters in. Okay, so all those sides correspond because they have the same position. All right, well, let's look at this side here, side BC. That corresponds to side EF, which corresponds to side YZ. And then last, we're going to look at side AC, which corresponds to side DF, which corresponds to side XY, or sorry, XC. So remember, I said to write ratios for corresponding sides, and a ratio is just a fraction. This is what I'm going to do, guys. So I'm just going to write fractions. For each of my triangles, I'm going to write ratios of the yellow side to the green side, and see what happens, okay? Then I'm going to check ratios or fractions of the green side to the brown side. And just hang in there. I know it's not clear what I'm doing right now, but I think you'll see what I'm talking about here in a second. Okay, so remember, ratios are just fractions, okay? So for triangle ABC, my yellow side measures 3, my green side measures 4. For triangle DEF, the yellow side is 9, green side is 12. And for triangle XYZ, yellow side is 5, green side is 6.5. Okay, so we have those fractions, but remember we need to check for the same unit rate. And you might be like, well, how do I do that? Basically, all you do is turn those to decimals. Remember this line right here? That line means division, so we're going to divide. So here's a nice time to get out a calculator. And the first one, I have to divide 3 by 4. So if I go 3 divided by 4, that gives me decimal 75. So the unit rate here is decimal 75. Next thing I want to do is 9 divided by 12. So if I go 9 divided by 12, that still gives me decimal 75. So I'm going to go back and write in my unit rate of decimal 75. And for my last triangle, I have 5 divided by 6.5. So we're going to go 5 divided by 6 decimal 5. That gives me decimal 769 and a bunch of other numbers. I'm just going to write decimal 769. Okay, so now let's check the green side and the brown side. So for triangle ABC, I'm writing the fraction of 4 over 5. For triangle DEF, I'm writing the fraction of 12 over 15. And for triangle XYZ, I am writing the fraction of 6.5 over 8. Now I need to do some division. So let's check 4 divided by 5. 4 divided by 5 is decimal 8. Now let's check 12 divided by 15. 12 divided by 15 is still decimal 8. And last, let's check 6.5 divided by 8. And we get decimal 8125. So remember, we're looking for the same unit rate. Well, if you look, when we checked, oopsies. When we checked the yellow side divided by the green side, notice we had decimal 75 right here and decimal 75 right there. That's the same, correct? However, it worked out for us right here. And then when we check the other two sides, notice we have decimal 8 and decimal 8. That's the same, right? But here, it didn't work out for us. So, since triangle ABC and triangle DEF have the same unit rates, we have determined that their sides are proportional, and therefore triangle ABC is similar to triangle DEF. So I'm going to write it in words. Triangle ABC is similar to triangle DEF because the sides are proportional. Remember, being proportional just means you have the same unit rates, which we do. Okay, there's a way to write triangle ABC. It's similar to triangle DEF in math, and here's the way we write it. We write a triangle, and then the name of the triangle, which is ABC. The similar to figure, or symbol, sorry, is this right here. It's just a wave. And then triangle DEF. So the last line that I just wrote is read, triangle ABC is similar to triangle DEF. Okay, so let's write some more. I'm out of room, so I'm going to have to clear my page, but we do have more examples. So you can continue on your page, or if you want to get another page, that's fine as well. So here's example 2. Example 2 is used for finding missing sides, and this is of similar figures, and scale factors. And again, the figures have to be similar. If they're not similar, then it's not going to work for us. So let's pretend like we have a picture. And our original picture is 5 by 6. Okay, so here's my picture. I'm drawing a tree. This is my original. Okay, let's say we really like that picture and we want to enlarge it. And when we enlarge it, the new size is going to be 17.5 by, and we don't know. That's what we have to figure out. Okay, so the question is, how do we go about doing that? There are 2 ways, okay? We can either find a scale factor and use it, or we can write a proportion. Okay, I'm going to do the proportion way first. To write a proportion, again, we have to identify corresponding sides. So that's what I'm going to do. I'm going to identify that this side that measures 5 corresponds to this side that measures 17.5. And then on the other hand, this side that measures 6 corresponds to this side that measures x. So I'm going to write a proportion, and I'm going to put my yellow side over my purple side. Okay, And you may be wondering, well, Ms. Brown, could I have put the purple side up top and the yellow side on the bottom? The answer to that is yes. The thing is whatever you do, just be consistent, okay? So if I look at my original figure, my original picture, the yellow side measures 5 units. And if I look at the original figure, the purple side is 6 units. Looking at my new figure, the yellow side is 17.5 units. And then looking at my new picture, the purple side is X units. So now we have a proportion. And the question is, how do we solve that proportion? To solve a proportion, we have two methods that we've talked about. We've talked about scaling and cross products. I think the easiest way for us to do this is to use cross products. So I'm going to draw my cross. So we have 5 times x is 5x. And then on this arm right here, we have 6 times 17.5. Let's get out our calculator and figure out what 6 times 17.5 is. That's 105. So we now have 5x equals 105. We need to get the variable x by itself, and we're going to have to do that by isolating the variable. Right now, x is being multiplied by 5, so the reverse of multiplication is division. So we're going to divide by 5, but what we do on one side of an equation, we must do to the other. So 5 divided by 5 is 1, so we have 1x on the left-hand side, and 105 divided by 5 is 21. So on my new figure, x is going to equal 21, okay? Now, another way we could do that is to use the scale factor. So here's how we do scale factor. To find the scale factor, we're going to look and compare our new picture to our original. So we're going to look for corresponding sides of the new picture to the original. So I'm going to look at the yellow side, okay? So I'm going to look at the yellow side of the new picture and the yellow side of the original picture. The yellow side of the new picture is 17.5 units long, and the new side, and the yellow side of the original picture is 5 units long. So now I have 17.5 divided by 5. Caitlin, come here. You heard me, come here. Pardon me, guys. 17.5 divided by 5 equals 3.5. So our scale factor is 3.5. Now, what is this scale factor telling me? That's telling me that what I'm doing to my original picture is I'm taking the original length and I am multiplying it by 3.5. I can use that fact to take the 6 and multiply that also by 3.5, and that gives me x. So let's put in our calculator 6 times 3.5. Okay, we're still getting 21. 6 times 3.5 is 21. So there are two different ways to solve the same problem. All right, guys, I hope this helped. Talk to you later. Bye-bye.